So we're going to start with the part C of our earthwork and excavation lectures, in which we're going to focus mostly on the mass diagrams. This is going to be video 1 of 3. We're going to have 2 more videos. So let's start by introducing the concept of a mass diagram. Our learning objective is going to be both focused on developing the mass diagram, calculating the haul distances, as well as analyzing the mass diagram to determine the slope for each operation and the equipment to use. This is a typical mass diagram. It's really a graphical representation of the amount of earthwork that we move along a center line, like basically a profile of the earth, over which the earth and the material are going to be transported. So if you look into this curve, the idea is that we are trying to show the amount of cuts and fills, the earthwork that's going to be conducted all through the stations. So you can see clearly that you have your cumulative cubic yards volume of earthwork to be moved, and on the x-axis you have your stations, your various stations, and this really, the blue line is going to be showing you the different amounts that we're going to be discussing in details further. The mass diagram technically answers questions like, where should I use these types of equipments? So what types of equipment should I use for what distances? The quantities and types of material needed, and if they're available, should I borrow, or should I actually, do I have excess, and in this case, should I dump, and where should I dump? Which cuts to use for which fills, and this is the beauty of the mass diagram, is to basically calculate the average haul distance and to figure out what would be most economical. As well, we have the average haul distance and the average slope for each operation, as well as how to minimize the travel distance, and we will see this clearly in our example. This shows a typical profile of cuts and fills. You see the different stations, you can see the cuts, so you see a medium-sized cut, a large fill, a smaller size cut, and then a smaller fill. And they happen all through the different stations that we can see here. Again, looking through this profile, it is interesting to see the cuts and fills. However, we don't exactly know what is happening in that specific station, because this is really the net cut and fill in every single station. For example, looking at station 8, let's look closely, and following here, we can see that there are different ways in which station 8 could look like. This is a scenario, this is another scenario, this is third scenario, fourth scenario. So technically, the profile is good in giving us the cuts and fills but at each station, but it doesn't quite provide enough information for us to figure out how we will perform the operation, which the mass diagram does. So let's look at the mass diagram. The vertical axes are my cubic yards, as I mentioned before, which could be either excavation or embankment. The horizontal axis is the stationing. And then you have your mass ordinates, which is really the cumulative total of excavation and embankment on the project. So the blue line here is what I mean by the mass ordinates. As you walk through the mass diagram, as you're moving uphill, so this uphill line, it's meaning that we are cutting. As you're moving downhill, anytime, whether it's up, positive, or negative, it means that you're filling. If you're on the top side of the curve, it means that you are mostly in the cut area. If you're at the bottom side of the curve, means that you're mostly in the negative fill area. So let's move on and let's look at the flat line here. And this flat line, we're going to call later our primary balance line. There are some balance points at these primary balance line, which are these points I'm pointing at with the mouse. These balance points is where exactly the diagram intersects with the baseline and indicates where the cut and fill have balanced out. What does that mean? That means that from this station 0 all the way to the station where the balance point actually happens, where basically the curve intersects with my horizontal axes, this area is a 0 cut and fill, meaning that the curve that is going up is actually filling the curve that is going down, meaning that in the stations from 0 to the midpoint of this curve, we are cutting. Whatever we're cutting, we're going to be filling in the next station. Let's look at this again. In this station, let's say station 18, we are going to be cutting all the way to station maybe 22, and then later we're going to be filling from 22 all the way to maybe 26. As we look into the mass diagram, there are certain information and definitions that we need to understand. The first one is going to be the haul. And the haul is technically what we transport. It's the amount of effort that we need to transport. And it's basically the excavated material that's going to be transported from the cuts to the fills, from its original position to its final position. We call it the authorized haul. There's also the average free haul. The average free haul is determined from the mass diagram. And this is really the area of the mass diagram representing the number of cubic yard stations of haul between the balance point divided by the ordinate of the mass, which is the yardage it's hauled. We are going to discuss this in a lot of detail as we move on. So for the meantime, just to get an understanding, when we move from station A to B, a certain amount, so we're cutting from A to B and we're moving it to B to C, it doesn't mean that we are actually going to move all the distance from A to C. So there's going to be an average haul distance for the material, and that is what we're interested in. Finally, the overhaul is going to be the authorized hauling in excess of the free haul distance and beyond the balance points. So in excess of my average haul, this is going to be the overhaul. Now, these parameters are very important because these are going to be used to determine our cost. These are things that we need to look clearly into the specs to see what's authorized and what's not authorized to figure out how we are going to be determining our cost. So obviously from the mass diagram, we could be able to determine the average haul, the free haul, and the overhaul. And then we could tell the contractors and the inspectors the quantity of material moved and how far it could be economically moved. And we will see an example later that shows us how the economical factor of the story is involved. We need to note, as I said before, that the cost of excavation includes the cost of transporting the material as well. So it's not just about cutting, but it's also transporting it from your cut to your fill. And the maximum distance that you can transport is going to be the free haul distance, meaning that you're going to be paid for it. But transporting material for a distance greater than that free haul is going to be called the overhaul distance. And this is important for our costing purposes. From the mass diagram, as I mentioned, you need to calculate to get two main items, and we are going to solve a problem about that, which is to compute our average haul or free haul, and these are the area under the curve and the volume, which is usually the sum of the peaks and valleys on the diagram. And the peaks and valleys on the diagram will be also described later. With the average free haul, we are going to be determining when and where to pay for the overhaul, because now we know what the average haul value is. When you exceed this value, you might have to begin to pay overhaul. And there are a few exceptions to that. This is when you are exceeding the average or free overhaul is basically going to be paid. But overhaul is only paid if you're outside of the balance points. And the balance points are the ones in which I was talking that were intersecting the curve with the horizontal line, or the horizontal line that we call the primary balance line. This means that if your average or free haul distance is exceeded within the balance point, you do not have to pay for overhaul. So this means that it would be optimum to have all your cuts and fills being done along the stations, along the project profile. This actually concludes our video 1, very short introduction of mass diagrams. We'll move on to video 2, where we're going to basically get closer to the mass diagram and understand how to read it, calculate the average haul, calculate the slope. Because we're using different pieces of equipment, we need to determine what the slopes in cut and fill that we are going to be using are, and then we are also going to be interested in figuring out our load haul plan.